Hi, I'm Austin, and I'll be showing you today how to measure temperature with the thermistor and an Arduino kit. Today we're going to need our power module, our breaker board, a 10 kilo ohm resistor, our thermistor, 2 LED bulbs, handful of jumper cables, and I personally use a multimeter, but it's not required. The reason why I use the multimeter is because we want to prove or determine if this is 10 kilo ohms. Because if it's not, we're going to run into some problems. So it's real simple. Just do it on each side like so. And 10 kilo. So we're good. Set that to the side. All right, so we're going to take our breaker board. And on the LED light, as you can see, there's two different prongs of two different lengths. Now all that means is the shorter one's always going to be the ground. So since the shorter one's the ground, we're going to put that on the blue side. Like so. And with our red LED, we're going to do the same, shorter side on the ground. Like so. Should look something like that. Now you can set them wherever you want on this. I just personally chose this side right here. Next, we're going to take our 10 kilo ohm resistor. I'm going to put it at 60 down here. Like so. Then we're going to take our thermistor and put it in a series right on 55 and 60. Now it doesn't have to sit in there super tight, just as long as it's in there is fine. Like so. So next we're going to take our jumper cables. We're going to need 3 of them for this down here. Our first one is going to be our ground. Next one on 60 is going to be the A0. And the next one on 55 is going to be our 5 volt. And on our power module, we can see there's ground on the other side. There's 5 volt and A0, which is what we want. So we're going to use this side. So our first one goes into ground. Second one into A0. And then 5 volt, like so. Looks something like that. Okay, next you're gonna want longer jumper cables since it's a bigger distance, and I don't think the shorter ones will fit. So the first one's gonna be ground. So the same concept as these over here. We're gonna put our ground on the blue side. And then we're gonna do 9 to red. And then we're going to do 8 to green. Just double checking that our jumper cables are in there nicely. The final product will be like this. Now you don't have to set your pieces exactly where I did. As long as they're in series, you can use wherever on the jumper board, but I decided to use these spots. So once we have this, we're going to come over and use our software. Now all this will be provided by your professor. You're just going to have to type it in there or code it yourself. All it's basically saying is just what I explained. Our first resistor is 10 kilo ohm. These numbers right here are going to be provided by your professor, or you can search a database for whatever you're using. 9 goes to red, 8 to red. And if everything looks fine, so we can actually change our delay. We'll do 700. You're going to go to the check mark up here to verify it. And if everything's fine, then we're ready to test it out. So then, since our software looks good, and if we've done everything right, our green LED should light up when we plug it in. Which, we did it right. So, if we apply heat, it immediately goes red. We take the heat away, green. And we can see on our software, make it bigger. we go to Tools and Monitor, we can see that the temperature right now is 75 degrees, which we set our parameter at 90 degrees. So that means that it's less than 90 degrees, so our green LED's on. As soon as we apply heat, it goes red, and we can see over here that immediately goes to 96 degrees. I removed the heat now, so it's going down, back down. But we can also go to a plot and see on a graph. So when we add heat, goes up, take away the heat, starts to go back down. So if we look here, this is our flow diagram. And you might be asking yourself, well, how does a thermostat read temperature? And the simple answer is it doesn't. What it does is a thermistor's resistance changes with temperature, so as resistance decreases, temperature will increase, and vice versa. If temperature decreases, your resistance increases. So we can use a flow diagram to kind of understand that a little better. So all this is saying is if our temperature is greater than 90 degrees, then our red LED is going to be on. So if our red LED is off, that either means two things: that it's less than or equal to, which means your green LED is going to be on. If nothing's on, that means you did something wrong. You got to check your system, see if everything's plugged in correctly, or maybe you did a parallel series, you know. But that's basically it. Thank you guys.